GCF and LCM stand for greatest common factor for GCF and lowest common multiple for LCM. So essentially GCF is the biggest small piece or factor as we break it into pieces, and LCM is the lowest multiple or big piece. As we grow the numbers, what's the lowest number that is common to two sets of numbers? So these problems relate to these situations relate to greatest common factor and lowest common multiple. So let's take a look at this first question. 20 red poker chips and 24 blue poker chips need to be arranged in a rectangular array. So we're going to put our 20 in rows and columns here. We're going to put 24 in rows and columns here. And they need to be done so that all the number of rows here match the number of rows here. And we want to have the widest, so we want to maximize this length. Okay, so with 20 I can do 10 this way, 2 rows of 10, but the problem is I can't do rows of 10 for 24. So what is the biggest number that I can have along the rows? Well, in this case here, if I can arrange 20 in 4 rows of 5, and I can arrange the 24 into rows of 4 rows as well. In this case, it would have to be 4 rows of 6. And that gives me my 24 blue poker chips. Okay, and since this is rows and columns, we're talking about multiplication or groups. There are no other groups that I can use. I can use, if I try 5 rows, I cannot arrange 24 into 5 rows. I can use again 10. Well, we tried 10 doesn't work. 12 doesn't work. So this is going to be 4 rows is the widest possible rectangle I can do. Now, since this is a common side length or common number of rows here, okay, so this is my rows, we're talking about a common side length or common factor. So the widest rectangle possible is going to be 4 rows, and this represents the greatest common factor. Okay, so this is a GCF problem. So it's greatest common side length, or in other words, the greatest common factor is going to be 4 for these two sets of numbers. So here's a lowest common multiple problem. So I have 2 tracks. Okay, one track is 12 feet long, so here's my 12-foot long track here. Okay, so I have 12 and 12, and I can keep on growing this or multiply it. Okay, so we're growing this. And then I have another length is 9, so this is 9 and 9. And I can grow this length as well, but I grow this in groups of 9. And what we want to do is we want to know when is the first time that the edges line up. Okay, so if I were to grow this to 36, okay, and I can grow this to 27, grow this to 27, and then one more will grow to 36. 36 then represents the point at which both of these are the same length, okay, or the multiples are the same length, or the multiples are common. In fact, this is the first time that happens, so it's the lowest common multiple. So this is going to be, we need to go, in this case, 36 meters until the ends meet. Okay, and this is the lowest common multiple because this is the first time that happens, and I can then go another 36, and I'm going to be able to make the edges meet again, and another multiple of 36. So once I hit 36, that's my lowest common multiple, and I can just use that multiple then to create even more multiples. But 36 is the first common multiple. So this is our lowest common multiple. So here we have common side length problem. That's a greatest common factor problem. Here we have a common multiple problem. So this is a lowest common multiple problem.